Alright, thank you. My name is Stephen, and I'll be covering the finite element analysis, which was both my responsibility and Isaru's, who also helped out with this section, but only one of us will be speaking since these are pre-recorded. So firstly, for the FE analysis, we wanted to cover several aspects of the gearbox. Most importantly was ensuring the gears can handle the stress. So we wanted to do an analysis at each of the three gear mesh steps to ensure that they're each up to scratch. By using the worst case scenario is how we want to go about. So that would be where the secondary gear becomes completely jammed and won't move. Thus, the first primary gear would transfer all of its torque onto the secondary, which would give the maximum tooth stress. So this would ensure that if it passed this test, there'd be no failure of the gears under any reasonable circumstances of operation. The gearbox case was also to be checked to ensure it was capable of holding the motor with the just two screw connections existing for the motor, and also further checking the two mount points are capable of holding the case, considering the moment that it receives from the weight of the motor, as well as any moment from some horizontal forces coming from the weight or rope if it was to be snagged, or in startup of motion when it's still under static friction where it undergoes the most force. There may be a little bit pull on it. Chances are it won't affect the case, but it's still worth a check. The shaft should also be considered, particularly the output shaft for similar circumstance. So this is ensuring that the maximum force output would not deform the shaft. So because it is attached through a hole, if it was to become snagged or during startup with the maximum force, making sure that it didn't deflect at all and it wasn't going to unmesh the gears or have any negative effects, and also making sure it can just hold up the weight of the gears, because in normal operation the shafts won't undergo much more stress than that. So onto the FEAs that were actually produced. So the results we managed to produce were just on the last step, or the last mesh, which is between the pinion and the 54 tooth gear, which is the smaller of the gears. And that was chosen as a priority due to experiencing the highest torque, being that it's at the last step and attached to the output shaft. So a torque of 0.16 Newton meters was used, being the presumed torque that'll be required to move the weight. And unfortunately, the result did show that it was over yield for acrylic. The stress is very localized, all located around just the tooth in contact, and this is representing the worst case scenario within reasonable operation as well. So during regular operation, likely that these amount of forces wouldn't actually be reached, but in a worst case scenario, it would fail. Displacement was minimal at only 0.27 millimeters, which means there's very little movement within the gear mesh. So it would really only be it works or it fails catastrophically. So close up on the next slide there shows just more zoomed in version where you can see the stress is very localized to the tooth, just in the joints and the corners, and the displacement is quite minimal. So being able to either even round off those corners or applying a mesh control may actually bring those numbers down and bring the stress below yield. So unfortunately not any more FEAs were produced. So finally I did want to touch on the problems that we had come across. So Isaru and I both had 2018 SolidWorks due to having done subjects in it previously, and they were not compatible with the 2019 SolidWorks that was used to design the gearbox, which we didn't really think about or come across until it was a bit more later on, and neither of us were able to upgrade or install the new version, just purely down to laptop errors on both of our ends, which was a bit unfortunate. I managed to use Citrix to get access to 2019 SolidWorks, and I then got to the meshing stage of these two gears, but with many hours of trying, it wouldn't be able to perform the final solve. So you'd be able to mesh it, and then once clicking the final solve, it would just freeze and sit there indefinitely, never getting through the first step. So Isaru managed to travel to a friend's place, get access to a computer that had 2019 SolidWorks on it. So definitely big thanks to him, because he was able to just pretty much run the FEA that was prepared through Citrix and get us the result that you saw. So there is still a lot of work to do in terms of completing the FEA work that we wanted to have to get a complete, accurate representation of how the gearbox will perform. And despite the results from the FEA, I do have reasonable confidence that the gearbox would still be able to perform properly under normal loading conditions. Thank you for your time, and any questions, please.